The general formula in finding the nth term of a geometric sequence is given by the formula a sub n is equal to a sub 1 r raised to n minus 1, where a sub n is the last term, a sub 1 is the first term, r is the common ratio, n is the total number of terms in the given sequence. In our example number 1, the first term or a sub 1 is 3, the common ratio is 3, and all we need to find is the a sub 7 or the seventh term. Given the formula, we have a sub 7 is equal to 3, 3 is the first term, times 3 is the common ratio, raised to the exponent n. N is 7 because we're looking for the seventh term. So 7 minus 1. And that is equal to 3 times 3 raised to the exponent. 7 minus 1 is 6. And that is equal to 3 times 3 raised to the 6th power is equal to 729, or 3 is being multiplied to itself 6 times. So that is 3 times 3 times 3 times 3 times 3 times 3. The answer is 729. And 3 times 729 is equal to 2,187. Therefore, the seventh term is 2,187. For our example number 2, a sub 1 or the first term is 5, the common ratio is negative 2, and we are looking for the 8th term or a sub 8. Using the formula, a sub 8 is equal to 5, which is the first term, times negative 2, which is the common ratio, raised to the exponent n. So we have 8 terms, so 8 minus 1. And that is equal to 5 times negative 2 raised to the exponent. 8 minus 1 is 7. Therefore, we have 5 times negative 2 raised to the 7th power is negative 128, or that is equal to negative 2 times 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 negative 2, and that is equal to negative 128. And 5 times negative 128 is equal to negative 640. Therefore, the 8th term of the geometric sequence is negative 640. Our next example is a sub 1 or the first term is negative 2, the common ratio is negative 2, and we are tasked to find the 9th term or the a sub 9. Using the formula, we have a sub 9 is equal to negative 2, which is the first term, times negative 2, which is the common ratio, raised to the exponent n minus 1. So n is 9. 9 minus 1 is equal to negative 2 times negative 2 raised to the exponent 9 minus 1 is 8. And that is equal to negative 2 times 256, because negative 2 times 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 negative 2 is equal to 256. Therefore, negative 2 times 256 is equal to negative 512. So, the 9th term of the geometric sequence is negative 512. We can also use the formula a sub n is equal to a sub 1 r raised to n minus 1 in finding the geometric mean, or in finding the terms between terms. For example, we have 4 as the first term and 324 as the last term, and we are tasked to insert one geometric mean in between. Okay, so to solve for that number, we have to follow the same formula, and the a sub n, or the last term, is 324 is equal to, the first term is 4 times r. We don't know the value of r, or the common ratio, so we will solve for it first. Raised to the exponent n minus 1. What's the value of n? How many terms are there in the given? So we have 1, 2, 3. So n is 3, so it will become 3 minus 1. Okay, so we have to copy 324 is equal to 4. Just copy 4, r. 3 minus 1 is 2. And to solve for r, we will eliminate 4 by dividing both sides of the equation by 4. Okay, so 4r squared divided by 4, it will become r squared is equal to 324 divided by 4, that is 81. To solve for r and to remove the exponent 2 in the variable r, we need to extract the roots. The square root of r squared is r, and the square root of 81 is 9. So our common ratio is 9. So to solve for this missing term, or for the missing geometric term, we simply multiply 4 by the common ratio of 9. So 4 times 9 is 36. Again, 4 times 9 is 36. Therefore, our second term is 36. Another way of finding the geometric mean is to divide the last term by the common ratio of 9. That is 324 divided by 9. Still, the answer is 36. Therefore, we have now inserted one geometric mean between 4 and 324. Our next example is to insert one geometric mean between 8 and 72. Okay, so to find for the second term, we have to follow the same formula. A sub n, or the last term, is 72 is equal to, the first term is 8 times, we don't know the value of r, or the common ratio, and n is 3 because there are 3 terms, 1, 2, 3. So 3 minus 1. Just copy 72 is equal to 8 times r raised to 3 minus 1 is 2. Again, to eliminate 8, we simply divide both sides of the equation by 8, and 8r squared divided by 8, that is r squared. 72 divided by 8, that is 9. And to eliminate the exponent of the variable r, we extract the roots of both sides of the equation. The square root of r squared is r. The square root of 9 is 3. Therefore, the third term, or the second term, can be found by multiplying 8 by 3 or by dividing 72 by 3. So 72 divided by 3, the answer is 24. Or 8 times 3, that is 24. Our next example is to insert two geometric mean between 5 and 32, or between 5 and 320. Again, we're going to insert two geometric means between 5 and 320 by following the same formula. We have the last term is 320 is equal to, the first term is 5 times r is unknown, and the value of n is 4 because there are 4 terms. We have 1, 2, 3, 4. So that is 4 minus 1. Just copy 320 is equal to 5. R raised to 4 minus 1 is 3. To eliminate 5, we have to divide both sides of the equation by 5. So 5r cubed over 5 is r cubed. 320 divided by 5, that is 64. And to remove the exponent 3, we need to extract the cube root of both sides of the equation. The cube root of r cubed is r. The cube root of 64 is 4. And to find the second term, we simply multiply 5 times 4, that is 20. And to find the third terms, we simply multiply 20 times 4, and that is equal to 80. We can also find it using the reverse. So we have 320 divided by 4, the answer is 80. 80 divided by 4, the answer is 20. In our next example, we're going to insert 3 geometric means between 20 and 8,920. By just following the same formula, we have 81,920 is equal to the first term 20 times r raised to the exponent 5 minus 1. The value of n is 5 because we have 1, 2, 3, 4, 5. We have 5 terms. Therefore, that is equal to 81,920 is equal to 20r raised to 4. 5 minus 1 is 4. And divide both sides of the equation by 20 to eliminate 20 here. 20r raised to the 4th power divided by 20 is r raised to the 4th is equal to 81,920 divided by 20, that is equal to 4,096. And to remove the exponent 4, we need to extract the roots. So the 4th root of r raised to 4 is r. The 4th root of 4,096 is 8. Therefore, our common ratio is 8. And to get that second, third, and fourth geometric mean, we simply multiply 20 times 8. And 20 times 8 is 160. For our next term, we have 160 times 8, that is equal to 1,280. And for our next term, we have 1,280 times 8, that is equal to 10,240. Therefore, our 3 geometric means between 20 and 81,920 are 160, 1,280, and 10,240.